In the previous video that we had for mole to mass and mass to mole conversion, we stopped with density. It wasn't actually explained that much. So when we talk about density, we mean mass over volume. So when density becomes an extension of the problem, that means you can't proceed to having density related calculation in STOIC unless you have one variable, which is the mass. And either you'll get the volume from it or the density given the volume. So in the last example, in the previous video of mole to mass to mole conversion, we stopped with this problem of aluminum oxide formation. So we begin with a balanced chemical equation of 4,3,2,4 aluminum, oxygen, and aluminum oxide in the chemical equation. So in this case, you're given 3 moles of aluminum, and then you're asked for the grams of aluminum oxide. So this is a mole to mass conversion, so that's why we put 3 moles of aluminum the given, and then to be followed by the mole ratio between your aluminum and your aluminum oxide. And then next will be the molar mass of aluminum oxide, so that you can arrive at the gram aluminum oxide in the final answer. So canceling the units we don't get and putting all the values in the calculator, we will now get 152.94 grams aluminum oxide, which is the mass of aluminum oxide. The second question in this problem says that given the density of aluminum oxide to be 3.69 grams per cubic centimeter, determine the volume of this amount in aluminum oxide. Now let's continue the calculation. Now since we know that density is equal to mass over volume, and we know that we're given density and we have the mass, that means we need to get volume. Now, how do we get volume? Now, take note, when we have a density formula to manipulate the equation to derive volume, you need to cross multiply that. So, density over 1 and then mass over V. Cross multiplying that, that becomes mass times 1 is mass, and then D times V is dV. Now, V is on the right side. So how do we get rid of the D? So we divide both sides by D. Therefore, to get volume, volume is equal to mass over density. Now, we know the mass, which is this, and the volume is given to be here. So we can now calculate. So volume is now equal to mass, which is 152.94 grams over the given density is 3.69 times 10. 3.69. Let me erase that. 3.69 grams. Let me put the unit like that. Grams per cubic centimeter. So putting that in the calculator, and you check that the units are compatible, because you can easily cancel out your gram in here. You can cancel out the gram because it's dividing. So you ended up with the unit cm cube. Inputting this in the calculator, 152.94 divided by 3.69, so you get the volume to be 41.45 cubic centimeter. So this is now your final answer of the volume of aluminum oxide that is equivalent to this mass that we got from here that reacted to our 3 moles of aluminum. So I hope that this makes it clear how we approach a density-related problem in stoichiometry. Always take note that density is mass over volume, and if you're calculating for volume, it is mass over density, and if you're calculating for mass from density and volume, if it's a basic calculation, that's density times volume. So that's it for density.